Hello class. In this video, I am going to discuss thin-walled pressure vessels. Okay, ano nga ba yung thin-walled pressure vessels? Pressure vessels class are cylindrical tank or container carrying a fluid under a pressure P, internal pressure. So, if the container is containing a fluid, it's either a liquid or a gas, which is pressurized under pressure. Now, there is a bursting force inside the tank that will cause maybe failure. It may cause failure to the uh, pressure vessel. So, sample pressure vessel in this picture is a cylindrical vessel and spherical vessel. Now, we are going to derive the formula for the internal stress or the stress of the material. So, let's say, for example, kung yung vessel natin is made of steel, ano ba yung stress within the material? Okay. So, let's proceed to the next page. We have what we call the tangential stress class. Okay. So, in this picture, let us consider a container, pressurized yung loob. I-consider nyo class is parang simpleng ano lang. Let's say for example, balloon. If you are going to increase yung gas pressure sa loob, hinihipan mo ng hinihipan, nagkaroon ng tendency na pumutok or mag-burst yung balloon. Ibig sabihin, nag-exceed siya dun sa limited internal pressure na kaya nung rubber. Okay. In other cases, yung mga containers na under pressure, like yung pinakita ko kaninang picture kanina, we are going to determine kung ano ba yung internal or the stress ng material so that we can design or we can set the internal pressure na kung saan kaya lang ng material kung saan made of yung vessel natin or vice versa. If meron kang desired internal pressure, ang kailangan mo is i-adjust is the material. You need to design na kaya yung internal pressure, yung load. Because the load here class is the internal pressure. Ito ang magiging load natin dito, yung pressure sa loob. Kasi yun yung bursting, mag-cause ng bursting force within the surface of the material na mag-cause ng failure kapag nag-exceed siya dun sa allowable. Now, ano ba yung bursting force? What is the magnitude of the bursting force? Okay, so this is pressure. Pag tingnan nyo class, distributed yan, uniformly distributed dito sa walls, sa internal walls noong vessel. Now, we cannot see pa the magnitude of the concentrated load. So, ang kukunin natin is yung internal force or the bursting force. We are, let F be the bursting force. So, that is the bursting force. Kunin natin kung ano yung value ng F. Ano ba yung F? Kasi dito class, ano yan eh, uniformly distributed. So, wala pa yung concentrated load. Now, pag tiningnan nyo dito, mag-consider tayo applying calculus class, derivation ng formula kasi. Mag-consider tayo ng element. No? So, let us consider an element. So, let us consider this as d theta. So, let's say, ito yung theta natin. Simula dito. Kasi, i-consider natin yung isang section lang. So, itong section lang na to. So, ang purpose natin dito, class, is to derive kung paano natin makuha yung F. Ano ba yung value ng F in terms of the internal pressure. Okay. So, yung F na yan, class, dito, no? So, magkakaroon tayo dito, kasi element lang yung kinukonsider natin. magkakaroon tayo dito ng value na df. Kasi element lang tayo. df tayo. So, in this region, in this portion, kukunin natin kung ano yung force, concentrated load na tumatama dito sa portion lang na ito. Element yung kinonsider lang natin. Applying calculus. And what is F? Diba, ang force natin is pressure times area because pressure, that is force per unit area. So, ang force natin is pressure multiplied by area. Ang pressure natin gagamitin is the internal pressure kasi yun yung tumatama dito sa internal walls noong vessel. So, we have the internal pressure, small letter P, and then multiplied by differential area. Element lang. Ano tong area na to? This area is the length of this arc, yung length nitong arc na to, multiplied by the length. Kasi this is the cross-section lang naman. The circular cross-sectional area nung cylinder. Nag-consider tayo ng cylinder. Now, from this element, so let's say, df, just copy the formula here, df is equal to P times dA. Kasi nag-consider tayo ng element kasi later, i-sum up natin siya. From theta equal to 0 to theta equal to 180 degrees. So, hanggang dito. Considering yung half ng cylinder. Okay. So, from here, we can say that F, ang F natin is yung single load na nagre-represent ng lahat ng pressure na tumatama dito sa half wall or dito sa semicircle wall na multiplied by L, yung area na yon. Okay, so makukuha natin yung F by, kasi class, yung element na kinonsider natin is not directly horizontal dito sa cutting natin, dito sa illustration natin. So, ibig sabihin, kukunin natin yung lahat na horizontal components nitong DF so that then isa-sum up natin siya, makukuha na natin yung value ng F. Kasi nakaslant siya class, nakaslant yan dito, given yung theta, yung limit, nag-move yan dyan, kasi summation ng strips, summation ng element. Consider lang tayo ng isang element, ito yung nire-represent nun. And then, kapag kunin natin yung F, yung summation na siya, that is equivalent because integral is summation, di ba class, sa calculus. That is integral of P dA multiplied by sine of theta. Why sine theta? Because yung horizontal component niya, ma-multiply ka ng sine nitong angle na to. Diba? From trigonometry naman yun. Okay, next. So, F is equal to, our limit is from 0 to 180 degrees. Now, F will be equal to integral of P. Ang dA natin is, what is dA? Ito yung differential area natin, yung element, that is length of an arc multiplied by L. Diba? So, that is equivalent to L. What is length of an arc? Diba? Length of an arc is equivalent to the radius multiplied by the central angle. And the radius is equivalent to D over 2, considering yung diameter. So, D over 2 multiplied by D theta. Because D theta is the central angle of that element na kinoconsider natin. Then, multiplied by sine theta. Okay. Labas na natin yung constant. We have P, D, L over 2 integral of sine theta d theta. Limit is from 0 to 180 degrees. Okay, manipulating the equation class, wala naman tayo sa calculus. So, review nyo na lang, makikita mo dyan that the integral of sine theta d theta is what? That is equivalent to negative, sige, so, i-ano na lang din natin. Review na rin sa calculus ninyo. So, integral of sine theta d theta is equivalent to, diba, that is negative cosine of theta. Limit is from 0 to 180 degrees. Then, kapag kinompute mo yung negative cosine 180 minus negative cosine 0, that is equivalent to 2. So, that will be equal to F is equal to PDL over 2 multiplied by 2. Kasi itong quantity na ito, yung quantity na yan, that is equivalent to 2. Okay? Okay, next. Cancel out na yung 2. So, obviously, F is equal to the internal pressure multiplied by the diameter multiplied by the length. So, this is the magnitude of the bursting force. This one, itong F. Same with kapag kinonsider mo itong kabila. Okay? So, since symmetrical naman yan, parehas lang yun. Another thing, class, is that in simplest way, the simplest way is considering this area. Yung bursting force, still yung F. Another way or the alternate way to determine the magnitude of F is simply from this figure, F is equivalent to, yung pa din, F is equal to internal pressure multiplied by the area. The area na i-consider natin is D times L. This one, itong shaded portion. So, F is equal to PD multiplied by L. Okay? So, same lang yun. Pero, by using calculus, yun talaga yung equivalent yung F. P times D times L. P as the internal pressure, D as the diameter of the vessel, L as the length of the cylindrical vessel. Okay, let us continue. Now, kunin naman natin kung ano ba yung magnitude noong tangential stress. Okay. The tangential stress. Okay, from this figure, class, you can see yung bursting force F is resisted by the two equal forces, T. Ayan. So, T along yan dun sa, that is tangential. Tangential yung direction niya dun sa circumference. That's why tinawag nga siyang tangential or circumferential stress. Tangential because the direction is tangent. It acts, the two forces acts tangent to the or parallel, it acts parallel to the it acts tangent to the surface of the cylinder. So this is the surface of the cylinder, it acts tangent. So kaya siya tinawag na tangential. Now, ano ba yung stress? Applying equilibrium, pag in-apply natin yung equilibrium, we have F is equal to 2T. What is F? We have internal pressure multiplied by the diameter times length. That is equivalent to twice of, okay, so nag-act yung T. T, so that is the tensile force tangent to the surface. Still, force pa din naman yung T. So, pressure times area or stress times area. Whatever is the stress dito sa material. Na? Okay. Kung ano ang stress niya, that is the tangential stress multiplied by the area. What is the area? That is L or thickness multiplied by L. Okay, from the equation, cancel out yung L. Makuha natin that the tangential stress is equivalent to PD over 2T. Okay, we have already the formula for the tangential stress. Okay, so sigma T from dun sa above is the tangential stress. P is the internal pressure. Take note, class, that the internal pressure is yung pressure within the vessel, kung gas man yan or liquid. Kasi pag sinabing fluid, it's either liquid or gas. So whatever the vessel, yung nasa loob niya, kung ano yung pressure sa loob, that is the internal pressure. And then, that is the diameter of the vessel. And then, T is the thickness of the vessel. Okay, so this is our final formula for the tangential stress. Okay, now let's proceed to the longitudinal stress. Okay, for the longitudinal stress, consider pa din natin yung vessel. Okay, meron na dito. Delete mo natin. Okay, dito naman sa longitudinal stress class, ang bursting force natin is nag-a-act doon sa end wall ng vessel. Kasi kanina, yung kanina kasi is parang something like this. Kung ito yung cylindrical vessel natin, kung ito yung cylindrical vessel natin, class, yung tangential kanina, yung nauna, ang bursting force niya is pag ganun yung direction natin. Yung ganon. Kapag naman yung longitudinal stress, ibig sabihin, pag ganon. Ang nire-resist nitong surface ng vessel natin is the end. Yung bursting force na nag-act doon sa end. Okay. Balik na tayo dito. Okay, balik tayo dito sa figure. Okay, so considering at the same time, pressurized nag-act dun sa wall, dito tumatama pa rin naman yan dito, let's consider yung longitudinal. Okay, so kung mayroon kayo ditong bursting force acting on the end wall noong vessel, so i-resist naman siya noong container. So, ang reaction ng container is mai-stress siya longitudinally. So, parang kumbaga pahaba yung direction ng stress. So, yung resisting force natin is itong P. Okay? So, ganun pa rin yung idea. The bursting force here is equivalent to the internal pressure multiplied by the area of the end wall. So, let's say that is pi d squared over 4. Kasi pressure multiplied by the area ng end wall. Okay. So, ang nagre-resist naman dito sa bursting force F natin is yung P sub T. And that P sub T is equivalent to the stress or the longitudinal stress multiplied by the area. Ano yung area na nagre-resist? That is the thickness nito, thickness multiplied by the length. What is the length of this portion? The length is the circumference. It is equivalent to circumference. So that is pi d multiplied by t multiplied by circumference multiplied by its thickness. That is the area nitong single load P na nagre-resist doon sa bursting force. Okay. So, applying equilibrium, we have F is equal to P sub T. Okay. So, copy the P pi d squared over 4. That is equivalent to sigma L pi d multiplied by T. Okay, so cancel out natin yung pi and also itong D. So, meron dito matitira na D. So, the longitudinal stress will be equal to the internal pressure multiplied by D all over 4T. Okay, so ito ngayon class yung ating longitudinal stress. Okay, the longitudinal stress is PD over 4T. So, same lang naman yung class, yung internal pressure pa rin to. Ito yung diameter, and then this is the thickness of the pressure vessel. Now, ano yung napapansin nyo? Kanina, flashback natin, the tangential stress is equivalent to PD over 2T. So, ano yung mapapansin nyo? The longitudinal stress is equal to 1/2 of the tangential stress. Tama? Okay. So, yung longitudinal stress daw is half of sigma T lang. So, based from the two equations, makikita mo naman that the longitudinal stress is half of the tangential stress. So, ano yung ibig sabihin nito? Okay, pag kinompare mo, it shows that the longitudinal stress is 1/2 of the value ng tangential stress. So, this is equivalent to stating na kapag ang pressure sa cylinder is raised to the bursting point, failure will occur along a longitudinal section or longitudinal seam of the cylinder. So, ibig sabihin daw, kasi class, let's say for example, pakita ko sa inyo yung mangyayari. Halimbawa, ito yung vessel natin. Na? Yan yung vessel natin. Sorry for my figure. Basta maintindihan nyo. Okay, ito yung vessel natin. May pressure yan sa loob. So, let's say pressurized tanks yan. No? So, may gas, mga oxygen, may pressure sa loob. Kapag na-reach niya yung bursting point, ano yung magiging failure? Sa inyong crack? Or ano yung hitsura ng failure? So, yung hitsura na magiging failure niyan, class, is something like this. Dito sa picture, sa page 1, meron tayo ditong this one. Burst pressure vessel. So, tinest siya, in-increase yung internal pressure until mag-fail. Ang naging failure is something like this. Okay? So, ganyan class ang nagiging failure when it comes to the tangential stress. Tangential stress kasi parang bumubuka yung ang direction ng failure pag ganito, pag tangential stress. Parang paano ko ba explain? Tingnan niyo tong cylinder na hawak ko. Kapag yung parang pabukas siyang ganun, pag ganun, na kapag tangential stress. Kapag naman longitudinal stress, parang ang nire-resist nitong vessel is pag ganun, pahaba, longitudinal. When it comes to longitudinal stress. So, obviously, by observation nga, makikita mo that the failure, mas maunang mag-fail, magka-crack yan, pag ganito, pahaba dito sa surface. Kasi, kapag nag-burst, ganun yung, bibiyak siya dito. Unlike nang yung pressure niya na pupunta dito, mahaba yung nag-resist sa kanya. No? So, mas unang mag-fail dito sa figure na to. Ganyan itong pinapakita sa figure. No? Okay. So, balik na tayo. Okay. Kapag naman circular yung container, so, dito na rin tayo. So, halimbawa naman, spherical. No? Kapag spherical siya, class, tapos, inano mo siya, hinati mo, na, kasi, by analysis lang, na para ma-derive mo yung, this is the internal pressure. So, this is the bursting force, tapos, ang nagre-resist naman yan is yung material. So, ano ba yung stress na nararamdaman ng material due to the bursting force? This bursting force naman is due to yung internal pressure. Tapos, as a reaction, itong surface na, itong spherical vessel, nai-stress siya, di ba? Nagkakaroon ng tensile stress. So, okay. So, ibig sabihin, let us consider this as, let's say, force P, T din. Na? Okay. So, F is equal to P sub T. F is still, kung ano yung area nun, circular area, pi d squared over 4, considering d as the diameter of the sphere, of the spherical vessel, and then PT naman is stress, yung stress ng spherical vessel multiplied by the area, which is the circumference multiplied by the thickness of the vessel. So, ang makukuha natin dito, class, is similar, class, wala tayo dito ng internal pressure. So, ang makukuha natin dito na stress ng material is equivalent to similar doon sa longitudinal stress, which is PD over 40. This is the internal pressure doon sa loob ng fluid, and then this is the diameter of the spherical vessel, and then the thickness. No? So, kapag spherical vessel, ito naman yung stress sa material. So, uniform naman yan kasi nga sphere siya. No? Unlike kapag cylindrical, meron kang longitudinal stress, meron kang tangential stress. Okay. So, solve tayo ng problem. But before that, meron kasing mga vessel, class, na balik tayo dito sa drawing ko. May mga vessel na hindi yung homogeneous, na may iba na riveted, or may mga gear, may connection. So, made of flat sheets, tapos gagawin lang siyang cylindrical in shape, tapos may joint siya na ganito. So, meron lang siya dyan mga connector. Tapos, dito naman sa kabil, meron ding ganito. No? Tapos, connected lang yan dyan. Now, when it comes to tangential stress, dapat matibay itong mga connectors na ito. Kasi, kapag sa tangential stress, kapag in-increase mo ng increase yung internal pressure, mas una yan mag-fail dito. Itong portion na to. Makalas yan kapag in-increase mo yung internal pressure. So, ito yung unang mag-fail. Okay? So, ibig sabihin, kapag may desired or meron kang designed internal pressure lang talaga, yun yung kailangan mo i-carry, kailangan mong patibayin is ito. No? Okay. Punta tayo sa sample problem. Okay, let us consider problem number 1. Okay, in the first problem, the wall thickness of a 4 feet diameter spherical tank is 5/16 inch. Calculate the allowable internal pressure if the stress is limited to 8,000 psi. Okay, spherical siya, class. So, obviously, magda-direct substitution ka lang dyan. Okay, let us solve the problem. The wall thickness daw is equivalent to 4 feet. And then, the diameter is 4 feet. The thickness is 5/16 inch. And then, the diameter is 4 feet. So, ang required dito is the allowable internal pressure if the stress is limited to 8,000 psi. Yan, class, na tinutukoy na stress, the tangential stress and the longitudinal stress, yan yung stress na nararamdaman or na-encounter ng material. So, let's say the pressurized vessel is made of steel. Ito yung steel, yung stress ng steel, ng material. Na? Okay, so what is being asked? The internal pressure. By direct substitution, we have the stress ng spherical vessel equivalent to PD over 40. Okay, substitute P. Unknown is P. Substitute the stress, which is 8,000, equivalent to the internal pressure. The diameter is 4 feet multiplied by 12 to make it in inches. No? 1 foot is 12 inches. Then, 4 multiplied by T. 5/16 inch. Sorry. Okay. So, the internal pressure, okay, calculate. Cancel out na yung 4 dito. magkakaroon ka ng 8,000 multiplied by 5/16 divided by 12. That is equivalent to 208.33. Okay, the answer, the internal pressure is equivalent to 208.33 psi. So this is now our final answer for problem number 1. Okay, next. For the next problem, problem number 2, solution na. Simulan natin from the start. Sorry. Okay. Para makasunod kayo, let us solve. Solve ko ulit ito. So, okay, the problem is a cylindrical steel pressure vessel 400 mm in diameter with a wall thickness of 20 mm is subjected to an internal pressure of 4.5 megapascal. Okay, the cylindrical pressure vessel, the diameter is 400 millimeters. Wall thickness is 20 millimeters. And then subjected to an internal pressure of 4.5 megapascal. Now, calculate the tangential and longitudinal stress in the steel. Okay, for the longitudinal stress or the tangential stress na muna, for the tangential stress, okay, so that is direct substitution lang. Okay, we have delta T is equivalent to PD over 2T. Okay? So, simple lang naman class. Alalahanin mo lang that the tangential stress is PD over 2T, then direct substitution. Okay, so the internal pressure is equivalent to 4.5. So, ilagay ko muna yung mga units para nakikita nyo. But, kapag sanay na kayo, kahit hindi na. Pero, dapat alam nyo yung mga units na ginagamit nyo. Pag substitute nyo ng mga values, kahit di nyo sulat yung unit, pero tanda nyo dapat para hindi kayo magkamali. Then, the diameter is 400 millimeters. All over twice of its thickness. What is the thickness? That is 20 millimeter. Okay, cancel out lang yung mm sa baba. Okay, so the tangential stress is equivalent to 4.5 multiplied by 400 divided by 2 times 20. Okay, that is equivalent to 45 megapascal. So this is our tangential stress. Okay, how about for the longitudinal stress? Okay, for the longitudinal stress, that is equivalent to half. Diba? Okay, so, based sa discussion kanina, longitudinal stress is half of the tangential stress. So, simply, pwede na nating i-divide yung delta T by 2. So, which is equivalent to 45, so divided by 2, magkakaroon ka ng longitudinal stress equivalent to 22.5 megapascal. So, we have already answered problem part A ng problem number 2. Punta tayo sa part B. To what value may the internal pressure be increased if the stress in the steel is limited to 120 megapascal? Okay, sa letter A, ang hinanap naman is yung mga stress, which is nakuha natin 45 MPa, 22.5 MPa, at an internal pressure of 4.5 megapascal. Ngayon, ang tinatanong naman is the internal pressure. What is the internal pressure daw? Kung ang stress is limited to 120 megapascal, no? So ang tinatanong naman is the internal pressure. Ngayon class, actually pwede mo nang gamitin is mamili ka na dun sa dalawa. Kasi, lagi naman nag-govern is the tangential stress kasi mas mauuna siyang mag-burst. No? So, ibig sabihin, yung allowable na 120 MPa, kapag ginamit mo itong tangential stress, pwede mo nang makonclude na yun yung internal pressure. Pero solve natin parehas para mas ma-realize nyo. When it comes to tangential stress, let us use tangential stress, considering 120 megapascal ang stress, consider it sa tangential, PD over 2T. So, let's say 120 yung stress, magkakaroon ka ng P multiplied by, 400 multiplied by twice of 20. So, what is the internal pressure? Okay, the internal pressure is 12 megapascal, considering yung tangential stress. Pag kinonsider naman natin yung longitudinal stress, meron tayong PD over 40. Ngayon, 120 is equivalent to P multiplied by 400 over 4 multiplied by 20. So, obviously, P will be equal to 24. The internal pressure, ito yung idea class. Ang tanong kasi sa letter B ay, ano daw yung load? Kasi yung, di ba sinabi ko, internal pressure, yun yung load. Okay, so what is the internal pressure daw kapag ang stress ay in-increase sa 120 megapascal? So, ibig sabihin, yung steel, kapag steel yung ginamit mo, na mayroong 120 megapascal yung kanyang stress ng steel, mas matibay yung steel, di ba? Ngayon, kapag sa tangential, ang kayang i-resist, when it comes to tangential, ang kayang i-resist ng vessel is 12 megapascal na internal pressure. Kapag naman longitudinal, ang kaya niyang i-resist na pressure ay hanggang 24 megapascal. Take note class, simultaneous yung nangyayari. No, simultaneously. Kapag halimbawa ang load mo naman ay, so mamimili ka ngayon sa dalawa, ano yung i-consider mo na internal pressure na kung saan kaya nung vessel, tangential stress saka yung longitudinal. So ibig sabihin, kapag 12 megapascal yung load na ginamit mo, kaya noong vessel considering tangential stress. Hindi siya mag-exceed 120 megapascal. Now, kapag ginamit naman natin na load, pinili nating final answer is 24 megapascal, oo nga, hindi siya magbe-burst considering longitudinal stress. Kaso, kapag 24 megapascal yung ginamit mo dito, obviously, mag-i-exceed sa 120 yung kanyang stress. Yung stress ng steel mag-i-exceed ng 120 megapascal. Kasi nga, kapag pinili mo yung 24. So, it doesn't mean na ang pipiliin mo ay yung 24. It should be the 12 MPa. Take note class that if you are going to, if the problem is requiring you to determine the safe load, always choose yung minimum na value, yung pinakamababa. No? So, kasi para kaya niya, when it comes to tangential stress, so obviously, kayang-kaya niya when it comes to longitudinal stress. Unlike kapag pinili mo yung 24 MPa, hindi kaya ng isa. No? Okay, so the final answer here in letter B is 12 megapascal. So, hanggang 12 megapascal lang yung internal pressure na pwede para kaya nung vessel when it comes to tangential and longitudinal stress. No? Okay. Letter C. If the internal pressure were increased until the vessel burst, sketch the type of failure. So, puto lang ito class, failure lang. Failure yan. Ano? So, kapag tinaas daw ng tinaas yung internal pressure, so ano mangyayari dun sa failure? Kapag Considering this is the cylindrical vessel, tapos in-increase mo ng in-increase yung pressure sa loob, so ang mangyayari dyan class na failure is ito. Na? So when it comes to tangential stress, ito ang failure. Kapag naman longitudinal, ang failure class is, anyway, mas nauuna namang mag-fail lagi yung tangential when it comes to tangential stress. Pero kapag, ito ang bumibigay, ganyan. No? Kapag longitudinal stress. No? Okay, next. Okay, next problem. Problem number 3. Okay, so start ulit tayo sa simula para masundan niyo. Okay, so ito yung given. Calculate the minimum wall thickness for a cylindrical vessel that is to carry a gas at a pressure of 1,400 psi. The diameter of the vessel is 2 feet and the stress is limited to 12 psi. So, ano yung hinihingi class? Calculate the minimum wall thickness ng cylinder daw na may internal pressure equivalent to 1,400 psi. Tapos, diameter is 2 feet and then the stress is limited to 12 psi. So, direct substitution lang siya class. Minimum wall thickness. So, considering tangential. Okay. Considering tangential, ang stress daw is 12,000 psi. So, this is 12,000 psi equivalent to internal pressure 1,400 multiplied by 2 times 12, the diameter, divided by twice of its thickness. The thickness is unknown. So, ito yung hinihingi ng problem. So, from here, makikita natin that the thickness is 1.4 inch. So, at a allowable stress na 12 psi, ang kailangan daw na pressure vessel is 1.4 inch ang kapal. No? Okay, but when it comes to longitudinal, considering the stress ng made of what ba to? Okay? So, wala naman sinabi. So, the stress ng vessel is equivalent to, the internal pressure is 1.4 multiplied by 2 by 12 divided by 4 times t. So, kahit dire-diretso pala. You can use pala yung longitudinal stress is half of the internal. Okay. So, relationship. So, obviously, t is equivalent to 0.7 inch. No? So, ang thickness daw, when it comes to longitudinal stress is 0.7 inch. Pag kinonsider natin yung longitudinal stress niya, ang kailangan niya lang na thickness is 0.7 kasi para sa kanya, kayang-kaya niya yung 12,000 psi. Samantalang dun sa tangential, ang kailangan niya is 1.4. Ngayon, nagde-design ka ngayon ng thickness, ano ang pipiliin mo? Is it 1.4 inch or 0.7 inch? Okay. So, ang pipiliin mo now, class, is the 1.4. No? So, this is the final answer. So, you are going to choose 1.4 inch as the thickness of the vessel na i-design mo so that kaya niya yung 12,000 psi. Kasi kapag ang dinesign mo ay 0.7, pagdating sa tangential, mag-i-exceed yan ng 12,000 psi or 12 ksi. Kasi kapag ang ginamit mo na t ay 0.7, pinili mo yung 0.7, so mag-i-exceed yan. So that will not be equal to 12,000 psi. No? So, sana naunawaan niyo yung konsepto, no? Or the idea. Okay, for the last problem, a cylindrical pressure vessel is fabricated from steel plating that has a thickness of, okay, what is the thickness? Thickness is equivalent to 20 mm and the diameter of the pressure vessel is 450 mm, the length is 2 meters. Determine the maximum internal pressure that can be applied if the longitudinal stress is limited to 140 megapascal, and then the circumferential stress is limited to, or the tangential stress is limited to 60 MPa. So what is being asked? What is being asked is the maximum internal pressure. So, ano nga yung internal pressure? The internal pressure ay yung kinoconsider natin na load. No? Okay. So, let us consider first tangential. Considering tangential, consider natin sa tangential stress, 60 megapascal is equivalent to P. The diameter is 450. The thickness is what? The thickness is 20 mm. Sorry. PD over 2T. Okay, PD over 2 times thickness na 20. So, what is the internal pressure? The internal pressure here is 5.33. 5.33 megapascal. Okay, considering naman na longitudinal, when it comes to longitudinal stress, considering longitudinal stress, the longitudinal based from the problem is 140 megapascal, equivalent to P multiplied by the diameter 450 divided by 4 times the thickness is 20. Makukuha natin that the internal pressure is equivalent to 24.89 megapascal. Okay, same lang class. Ang internal pressure yung load. So, alin ang pipiliin natin? Yung mas maliit. Ano? Kasi, yung 5.33 lang, kaya ng tangential. Ang longitudinal stress, when it comes to, considering longitudinal stress, equivalent to 140 megapascal, ang kaya niyang i-accommodate na internal pressure is hanggang 24.89. While yung tangential, ang kaya niya lang i-accommodate na load is only 5.33 megapascal. So, para kaya, pag pinili mo tong 24.89, hindi kayang i-resist when it comes to or considering tangential stress. So, the final answer here is the internal pressure is 5.33 megapascal. So, this is now the final answer for this problem. So, this is the maximum internal pressure. So, hindi ibig sabihin, class, kapag sinabing maximum, yung maximum value. This is the maximum safe load. Pag hinahanap natin is load kasi, ang pipiliin nyo yung mas maliit para both ways ay kaya. Na? So, this is the final answer. Okay, class. So, I think that's all for this video. So, I hope na unawaan nyo yung ideas and concept ng pressure vessels. Okay, that's all. Goodbye.